When we look at this expression, we find that
Gulu Ame, you are not discussing now. It's Moyo SS.
This expression is when we differentiate x raised to power 4.
I think more SS should share the screen, please.
Moyo SS screen is here. I can see Moyo SS screen, but they are not starting.
We are using Moyo SS2.
Moyo SS2.
Yes.
We see the blackboard, but we don't see you. Which one are you using?
Moyo SS2.
Yes, we can now see the blackboard. Go ahead.
Okay, fine.
2.
Find the integral x raised to power 3 t power x raised to power 4 s. This implies that when we look at the expression, we realize that when we differentiate x raised to power 4, we shall have a derivative function of x raised to power 3. Therefore, this implies that we shall say x raised to power 4 left.
I don't think I'm seeing Moyo SS.
X raised to power 4.
What are they saying? No problem.
Moderator, many people are complaining in the chat. They are not seeing the screen. I'm
Yes,
equally not seeing the screen.
I'm also not seeing the screen. Moyo SS. I think you are using Moyo SS, not Moyo SS2. But open your video, Moyo SS, and we see.
They are using Moyo SS, not Moyo SS.
Moyo SS2.
Yeah, we use Moyo SS2. The co-host has asked you to start your. You waited?
But the
Start.
word 2 is not there. Yes, that one. Moyo. There is a video we are seeing Moyo SS.
You tell him to give us a few seconds.
Moyo, can you speak to us? We see you.
Hello. Hello.
You tell him that the device
Presenter, could we maybe go to Gulu Ame as they sort themselves out?
Okay,
Hello,
Moyo.
Hello.
Moyo, we are seeing, I don't know, me, I'm seeing these 3 guys here. I don't see the blackboard. Maybe I go back to the.
I think they need more time. We could move to another school.
Okay, Moyo, can we come back to you? Let's go to Gulu Ame. Let's go to Gulu Ame now. Moyo, let's go to Gulu Ame. Gulu Ame, open your video. Gulu Ame, open your microphone. Gulu Ame. Do you think Gulu Ame is ready also? Kibingo girls, can you put up your arm, put up your hand and we see you, Kibingo girls? Ah, Gulu Ame has come. Gulu Ame has come.
Good afternoon, members.
Louder.
Good afternoon. So I'm called Local Alfred from Gulame Secondary Schools. I'm going to present number 13. Part A, which says the function of f of x equal to x cubed plus px squared minus 5x plus q. As a factor, here we have been given f of x equal to x cubed plus px squared minus 5x plus q. Then it says it has a factors. It has the factors of into bracket x minus 2. From here, f of x equal to 0. Since we are given the value of x to be factors as x minus 2, then we shall rearrange as x minus 2 to be equal to 0. Here we need to get the value of x. Then x minus 2 equal to 0. Once we take this negative 2 to the right hand, it changes to positive. So we shall have x equal to positive 2. Then this x, the value of x, we shall put it in this equation that's given here, as I've written it on top here. So I write as f into 2, since f of x is my value for f into 2. So it will be equal to, so where is the x? I'll substitute with 2. So yeah, I'll be having 2, but it's what? Cube plus my cube, which I don't know, into 2, but x is what? Squared, minus 5 into 2 plus q to give me what? 0. As I've stated here, f of x equal to 0. So now I make sure this, I equate or I get an equation from p and q. So by getting 2 cubed, it will give me 8. Then if I multiply, if I get the square root of 2, it give me 4. Then 4 times p will be plus 4p. I have here minus 5 into 2. It will give me negative 10 plus q equal to 0. So I will rearrange. I will see where equal numbers or the same number there are, like I have here 8 and negative 10. So I'll make sure I take this 8 where it's 10, then 4p be left on this side. Then I bring also my p to make them uniform. So it will be equal to 4p plus q minus 10 plus 8 give me 0. So now here I'll be left with 4p plus q, here be negative 2. Since 10 is carrying negative and is bigger than 8, which is positive, so I'll be left with negative 2 be equal to 0. So I'll make sure this side on the left, I left with p, 4p plus q minus 2. Then this minus 2 I will take to the right hand side. Then this sign negative here will change to positive. So f into 2 will be equal to 4p plus q equal to 2. This is my equation 1. So let's go and find the equation 2, and it reads, because this one was the first statement, I'm going to the second statement, which says, and as a value of 5 when x equal to negative 3. So here, as we say, it has a value of 5. When my x is what? Negative 3. But what? As what? A value 5. So again, I will go back to the same equation. F of x equal to x cubed plus px squared minus 5 x plus q equal to, so it's not yet equal to, we need first to substitute. Here they said x equal to -3, f into -3 be equal to, where there's x, I'll substitute with -3. Into bracket -3, but is what? Q plus p into -3, but is what? Squared, minus 5 into -3 plus q equal to, the value I stated as what? 5, not 0. Now, from this statement say a value of 5 when x given -3. So the other number we put equated into 0 because it was said, and that's a factor of x minus 2, why you could equate it to 0, but this one here equated to 5. Now, when you get a cube of -3, we shall get a -27 plus, when you get a square root or a square of -3, it will give us +9. Then +9 times this p give us what? Plus 9p minus 5 times -0 give us -15. But here we are subtracting. Here's what? A minus. So it will change this to addition sign. It will give us plus 15 plus our q give us what? 5. So now here having here -27, I will make sure I pick this one at 15. I put where is what? -27. Then here's the addition side. I'll just add plus 15 plus my 9p plus q equal to 5. So this one -27 plus 15, I will get, or I will remain with -12 plus 9p plus q equal to 5. So I make sure this -12 I take at the right, it changes to positive. Now you are left with it 9p plus q equal to 5 plus 12. 9p plus q equal to 17. This is my equation 2. So I will ask to find the value of p and q. After forming these two equations, I go and solve them. Solving equation 1 and equation 2. So equation 1 I have, my equation 1, I have 4p so 4p plus q plus q equal to 2. For the second equation, I have 9p plus q equal to 17. So I want to eliminate 1. So I've seen here, I have here q and q. So I'll just now eliminate them because you have 4p and 9p, but you have only pp. So that means I will not stress myself again multiplying all the same, or by 4 or by 9, but I'll just subtract. See here's the addition sign. Once I subtract, we will be left with 0. So 4p minus 9p, I'll be left with 5p plus my 0 here, because q minus q is 0. Then equal to 2 minus 17, I'll be left with -15. So now here, I'll be left with it -5 equal to -15. So I'll divide both sides by -5. So to be left with on the value of p, divide both sides by -5. So this one will know very well, just this negative sign will change it to positive. So here, when 5 divided by 5 is 1, then we shall be left with what? P. Then 15 divided by 5, we shall be left with 3, it goes 3. So this is our value of P. Now let's go and find the value of Q. I'll just work it out from the equation 1. Equation 1 from equation 1. 4p plus Q equal to 2. But my P equal to 3. So here I have 4, but here's what 4p. That means where's P? I will multiply it by 3. By 3. Then plus my Q equal to 2. 4 times 3 is what? 12 plus Q equal to 2. So from here, I want to take this 12 on the right hand side. I'll be left here on the left with the Q only. So Q will be equal to 2 minus 12. My Q equal to negative 10. Therefore, my P is 3, and my Q is negative 10. This was my solution for part A. So let's go to B part. Let's go to B part. It has stated as the roots of the equation ax squared plus bx plus c equal to 0 are alpha plus beta form the equation whose roots are alpha divided by beta and beta divided by alpha. From the equation, this is our part B. From the equation ax squared plus bx plus c to give us what? 0. So we are asked to form the equation of the roots given us alpha out of beta and beta out of alpha. So from here, I want us to go back to the equation given as ax squared plus bx plus c equal to 0. I make sure I've been left here with only x squared. So that means I'll divide both sides by a. So by dividing both sides by a, so here I'll be left with x squared plus bx out of a plus c out of a to give me 0. So from here, I want us to get the products and the sum from this equation here, because this product and sum, it helped me to work out or to find out the equation of the roots. So as we know, our product equal to a times c. So in my a has here 1 x squared, but my c is what? C out of a. That means my product alpha beta. This is my product as alpha beta. See, alpha times beta will give me alpha beta equal to, saying I want to get the product 1 times C out of A. I believe this C out of A as my product. Let's go to find sum. My sum is alpha plus beta. We know very well from there,
then thereafter
of the roots. It states x
Mr. Angela, there is somebody coming in from UK. I don't know, we'll know. We need to send him to one of the groups. He's going to join in now. We need to send him. Mr. Angela, are you there? Mr. Angela, are you there? Mr. Angela,
Yes, please.
are you there?
Yes.
Okay, there is somebody who's going to join in. Is calling in from UK. He was a teacher with us at Gaza School. He would like to join one of the rooms. Maybe you bring him to room 2.
I've been trying to send people to rooms, but I don't have those rights.
You don't have the rights.
Hey,
Oh, but I see you are a co-host.
yes, I'm a co-host. I've been using that one is on phone.
Ah,
I'm
okay.
trying to join, but it is not doing so.
No, Mr. Kaziba has to come back and make you a co-host with the one you are using, the lower one.
No, I prefer this one for the one for. They are all the same names right away. Let me just rename one. Let me rename one for laptop. If you could give me rights on this on the laptop, it would be easier. Okay, that one. Members who have just joined in, and we join the breakout rooms. There is breakout room 1 and there is breakout room 2. You can decide. If you're using a phone, at the top there is an icon with 4 squares with the word breakout. So just touch it and either join room 1 or room 2. If you're using a laptop, at the bottom where the menus are, you will see the word breakout rooms. And then when you touch it, you can either join room 1 or room 2. The discussions are ongoing in the breakout rooms.
It means negative b out of a, but it's what? Squared. Minus my 2 into my product is what? C out of a. Out of what? My product is what? C out of a. By squaring this b, negative b and a, I be left with what? B squared. Seeing this negative now will cancel. So square any number which is negative, but will now be left with what? Positive 1. Out of what? A squared minus. So this 2 here I might play with what is up, but not what's down. This 2 I might play with C. So I be left with 2C out of A. But all has been divided by my product is what? C out of A. Now, I want to make some changes here because now I write this one as B squared out of A squared minus 2C out of A out of C A. Then this one will be what? Then I first get this LC of this. LC of A squared and A is what? We shall be left with A squared. A squared. So this A squared divided by A squared is 1. Then 1 time B squared is what? B squared. Then A squared divided by A. I be left with the A. Then A multiplied by 2C. I be left with what? Minus 2AC. Out of C out of A. So now I bring this one as B squared minus 2AC out of A squared. I'm dividing this one here. The denominator. So I divide it as what? C out of A. Once we are dividing everything, that means we shall multiply and this letter will change. A will go on top, then C will come down. So B squared minus 2AC out of A squared times A out of C. As you know very well, 2AC is quite different from A squared. But here we have A out of C. That means this A can be cancelled with A squared. So once I divide this one by A goes 1. Here by A, I will be left with this A. So that means I'm having what? B squared minus 2AC out of A times 1 out of C. Then it's B equal to B squared minus 2AC out of. So I've been left here with A times C. So it will be AC. This is my sum of roots I got here. This is my value for sum. Value for sum is B squared minus 2AC out of AC. Now let's go and find the product. Let's go and find the product. With the products, we shall multiply and we shall not add the values, but we shall multiply them. Sorry. We have alpha out of beta times beta out of alpha. So alpha times beta, we shall be having what? Alpha, beta. Also here we shall multiply beta times alpha is what? Alpha, beta. So all this one carry the same letters. So they can be divided by themselves. So this one here, alpha beta divided by alpha beta is what? 1. That means our product equal to 1. As stated before from the equation of the roots, x squared minus into brackets sum of roots into x plus my product rules. My product rule roots equal to 0. So I make sure I'll just go and substitute. Where's my sum roots? I got it before there, and it is here. Then I will substitute where also my product as is negative is what? Positive 1. So I'll be left with x squared. Here's what? Minus my sum of roots is what? B squared minus 2AC out of AC, but all has been multiplied by x plus my 1 equal to 0. So this is my equation of the root. Let's go to part C. Part C says simplify it, root of 3 minus 2 divided by 2 root of 3 plus 3 in the form of root of 3 minus 2 out of 2, not 2, root of 3 plus 3 in form of P plus Q root of 3. From this step here, as we now know, we want to simplify this number here to make this number to appear in form of P and Q root of 3. So we shall make sure the denominator we shall multiply with what? But only the sign will change this from positive to negative. Let us try to work it out now. We have here root of 3 minus 2 plus what? Into brackets. So as I said before, 2 root of 3 plus 3, there's something which will happen here. So I'm multiplying this one here. So I'll be having what? Root of 2 root of 3. But here's a positive, but I change it to be negative. Why? Because we want to conquer the so minus 3 out of 2 root of 3 plus 3. So multiply this number by itself. So we 2 root of 3 minus 3. So we make sure that we multiply all the terms. I will start with my root of 3. I make sure this root of 3, I multiply with what is here. I multiply this root of 3 times 2 root of 3 minus 3. So root of 3 outside the bracket into, I pick this one here, 2 root of 3 minus 3 to bracket. So again, I'll be left here with negative 2. Then this, I pick this as negative 2. I will multiply with what is here into bracket 2 root of 3 minus 3 into brackets. So I make sure I multiply all the terms. Also, what I've been done. What has been done here also, I also do which one? That is what down here. So now 2 root of 3 into 2 root of 3 minus 3 plus 3 into 2 root of 3 minus 3. So yeah, root of 3 into root of 3 2 into root of 3 minus 3 minus 2 into 2 root of 3 minus 3. So yeah, 2 root of 3 into 2 root of 3 minus 3 plus 3 into 2 into root of 3 minus 3. So from here, from this step here, as you know very well, we are multiplying root of 3 times 2 root of 3. But here, I first bring out my 2. Why? Because I want to be left with the root of 3 times root of 3. Because this 2 here, even though I multiply this 2, this root of 3 times 2 root of 3, I'll be left with this 2 here. So now, any number, once it's carrying the root sign, and you are multiplying that the same number. Because as we know very well, root of 3 times root of 3, we shall be left with all the 3. Why? Because this one is the same. We are getting, yeah, if I multiply, you give me as root of 9. So now, if I get this one, it'll be what? Flat time 3. I will not get as root of 9, but I'll get as 3 only. Because this one will just cancel, then I'll be left with 3. So now, root of 3 times negative 3, I'll be left with minus 3 into root of 3. Also here, I multiply this 2 times 2 root of 3. It will give me negative 4 into root of 3. This 2 times this 3, because all they are contain the negative or they are contain minus, then this sign will change this to positive. Then this 2 times 3 is what? Positive 6 out of. Also here, the same what I've, because here 2 root of 3 times 2 root of 3, 2 times 2 is what? 4. Now what about 3? Root of 3 times root of 3, I've been left with what? On 3, but not what? Root of 9. So 2 root of 3 times negative 3. So it will give me what? Minus 6 root of 3. So here be what? I be 3 times 2 root of 3 is what? Plus 6 root of 3. So 3 times negative 3 is what? Minus 9. So now here 2 times 3 is what? 6. Minus what? Negative 3 into root of 3 minus 4 root of 3. I be left was negative 7 into root of 3 plus minus 6 out of 4 times 3 is what? 12. So here, negative 6 root of 3 plus 6 root of 3. Then this one just what? The cancel. I been left with what? Negative 9. So I make sure I correct the what? The like terms. So I have 6 and 6. So 6 plus 6 minus 7 into root of 3. Out of 12 minus 9 is what? 3. So 12 minus 7 root of 3 out of 3. We can split this one here. We can split them. So 12 out of 3 minus 7 out of
Hello?
7 out of 3.
Excuse me?
So this 12 can be reduced.
Okay.
So this 12 can be reduced by 3. So by reducing, it will give us what? A 4. Equal to 4 minus 7 into root of 3 out of 3. So we was just asked to write in form of what? P plus Q into 3. P plus Q into root of 3 as equal to 4 minus 7 root of 3 out of 3. I think I'm now done with my work.
Do you have any questions? Can you ask?
Do you have any question?
Look this way.
Do you have any question? Yes, I'm waiting for your question. If there's any question for me.
Yes, thank you very much.
Hello? Hello?
Yes.
Is there any question going ahead from the presentation?
There's
Otherwise,
Jean Marie. There's Jean Marie with the hand up.
Yes, hello? Hello?
Yes. Teacher Frederick, can you come in and guide?
See, I don't know if it co-host rights may not be able to speak, unmute himself. Is there someone?
There's Bale's camera.
Vale SS should be, Vale SS unmute and speak.
Mr. Dungu,
Yes. Yes.
I wanted to find out if you would hear us that side, and we have present already. I don't know whether
No,
they should start.
not now. Not now. We have some schools before.
Okay.
Can we move to the next school? Chivingo Girls. My moderator, Mr. Nambohe, who is coming. We had Chivingo Girls and we had the one who failed first.
Mr. Dungu,
Yes.
as far as I see it is concerned, Mr. Masaberisa, that is the Bale's camera, we can control. Is much better.
Okay.
So I request that he does so.
Okay, Mr. Masaba, last
Yes,
time there was a
Mr.
presentation very long.
I do what?
Is this a short presentation? Mr. Masaba, go on and present.
Okay, so maybe who is presenting? Proceed.
Kabingo Girls had a hand up.
Yes, you can go on.
Okay, good afternoon, listeners. Welcome to Uganda Virtual A-Level Maths Seminar 2023. My name is Namono Immaculate, going to Gombale Secondary School. So I'm so grateful for each of us that has been able to connect with us in order to share various ideas among ourselves. So at this point in time, I'm going to present number 7. And the question says, solve the equation tan theta minus 60 degrees equal to 3 of theta. Or negative 90 degrees less than theta less than 90 degrees. So our first solution would be, this is for part A. Our first solution would be, we are going to first get the tan identity, which is tan theta minus tan 60 degrees over 1 plus tan theta tan 60 degrees. So this would be equal to 3 times 1 over tan 30 degrees. Since we know that cot theta is, cot theta is equal to 1 over tan theta, right? So we shall continue by saying tan theta minus tan 60 degrees over 1 plus tan theta tan 60 degrees. This will be equal to 3 over tan theta. Okay? So So at this step, we are going to cross multiply. And when we cross multiply, we find out that this will be tan theta into tan theta minus tan third increase is equal to 3 into 1 plus tan theta tan third increase. Okay? So at this time, we are going to open the. So if we open the bracket, this will give us tan squared theta minus tan theta tan. So this will be equal to 3 plus tan theta. Sorry? 3 plus 3 tan theta tan step. So at this step, we shall find out that when you go tan is equal to 3 plus 3 tan. Sorry? This will be 3. So we are going to collect right now. When you bring the 3 this side, it will be a negative. So we shall have tan theta tan squared theta tan theta then minus 3 Now still bring this 3 this side. Tan squared theta. We know that when we are subtracting numbers, okay, when we are subtracting sides, we shall say this will be, there is a silent one here. Only hope you can see. So we shall have negative 1 minus 3. That gives us negative 4. Yeah, because you can see can dominating in this two steps, so it means that like so this will be minus 3 is equal to 0. We find out that this is the quadratic equation. So for that test, we shall let anyway, let's say m is equal to tan, and this will be m squared minus 4 is 3. M minus 3 is equal to 0. So we are going to use our method, our bulldozer method to get possible answers for m. So it will be defined by m is equal to negative b plus or minus root of b squared minus 4ac over 2a. So we need to first identify our values of a, b, and c from this equation. So a will be our a is 1, b is equal to negative 4, and c is equal to negative 3. So we shall just this will be negative. Negative 4 is 3. Plus or minus 4. Our b is negative 4 is 3. Whereas minus 4, a is times 1 times negative 3 over 2 times 1. So what do we get when we punch in this? Has anyone gotten the answer? Okay, no, I've gotten mine, and the answer is M is greater than 7.337 or our M is negative 0.4 from 8 to 9. So what happens when we count M? Remember, we want to find it cannot M. So we shall say when M is equal to 7.337, our tan theta will be equal to 7.337. So we shall get the tan inverse of 7.337 mass. Yes, for me, this part. Yeah, what's the answer? All right, the answer here I can see is 82.2388 degrees. I'll round it up to 4 degrees. No, but for this test, we don't have one variable. So we shall get another value from the quadrant. So let's have our quadrant. Here we have x. Here we have seen that our value that we have gotten is a constant. So we have to go further and look for other values where tan is positive. We find out that tan is positive here and tan is positive also inside the third quadrant. So what happens? Here we shall have 180 plus the value that we have calculated. So therefore we shall say that our theta is 82.2388, another one is the third quadrant, which is 180 degrees plus the value that we calculated, 2388. This will be 82.2388 degrees, Friends, on my calculator, I can see the answer is 262.23886. Quickly. All right, those are our values. When James is 7.337. So what happens when M is equal to negative 0.4089 degrees. So for this case, this negative is showing us the direction where tan is negative. So we shall consider the positive answer, but in our mind we said that the value we should place should be where tan is negative. So we shall say our tan theta equal to 0.4089. Sorry, this is not a degree. So we shall also get the tan inverse of 0.0408. This gives us here the answer is 22.2397 degrees. This is our friends here. Is it tan inverse of the value? So we are going to also get another value from our quadrant. Like I mentioned before, we are going to get another value where tan is negative. So when we go back to our quadrant, we shall find out that tan is negative in the Second. The second quadrant. So we have to get the second quadrant, we shall get 180 minus the value that we have calculated. So here we shall get 360 minus the value we have calculated. So we get about say our theta is 180 minus the value that we calculated. So this will be 180 minus 22.23 and 7. Sorry, this is 180 minus 22.2397. And this gives me 157.763. And then also we get 360 minus the value of calculated. This gives me 337.7603 degrees. So we now go back to our question. They say we can find to solve the equation for negative 90 less 90 degrees. It means our answer is going to go beyond the range of 90 or it's going to go in the side of negative 90. So what's happening? When you look at our values of theta, they start from here. We have this, and this already goes beyond the range. Please. So when you look at the values of theta that you have calculated, you find out that all these ones do not fit our range. So we get about home and say our theta is 82.2388 degrees. So that was part A. So let's switch on to part B. Part B saying we show that B over sin B minus sin B over sin B is equal to sin B sin B. So here our first step will be that we shall express time in terms of sine and cos. So we know that tan B is the same as sin B over cos B, but divided by sin B minus sin B over sin B over cos B. So we are going to get sin B over cos B divided by sin B. And this will give us sin B over cos B divided by sin B minus sin B divided by sin B over cos B. So when we get the reciprocal of this, we find out that B sin B over cos B times 1 over sin B minus sin B times cos B over sin B. So I can write it correct as cos B sin minus sin B cos B over sin B. So at this step, we realize something that sin B will cancel with sin B. Then sin B will cancel with sin B this side. So we shall remain with 1 over cos B minus cos B. What happens here that we shall get the LCM? And our LCM here is cos B. So cos B divided by cos B is 1. When 1 we get 1 minus our cos B divided by 1 is cos B. And cos B we get cos squared B. So we realize that when we go deep in our trigonometry, we have cos squared theta plus sin squared theta is equal to 1. So at this step, we want to obtain something that's 1 minus cos theta. So we make sin squared the subject. When we make sin squared the subject, this is 1 minus cos squared. Sorry, I've used the different thing. This is it. B. Cos squared B, sin squared B is equal to 1 minus cos squared B. So at this step, we shall just punch in here. See this. So having said this, we shall say sin squared B over cos squared B. We can break this further by saying sin B over cos B. Realize that here we have two different things. We have sin B over cos B, and we also have sin B over 1. And this gives us our answer as tan B sin B. So we therefore say, therefore our tan B over sin B minus sin B over tan B equal to tan B equal to tan B sin B. So we would have gotten our answer and say, let's prove. Thank you. Yes, oh friends, I forgot is there anyone who has a question? Anyone with a question? Okay, if there is no question, I wish you the best. Shalom.
No, sir. We have, I see one hand is up. I don't know whether you had the question. May I know? I see that hand is up. You want to.
This is the thing tomorrow public.
Please, if you're speaking, speak fast. My moderator, please type. Somebody who put up your hand, please speak fast. The person who put up your hand, please speak fast. Okay, Mbale SS, if you've completed, thank you. My moderator. Mr. Masaba, have you completed that?
Mr. Dung, somehow we're not having a comment, we're not able to hear each other. I don't know if you can now hear us.
We can hear you now.
Yes, now there was that hand that was up. I don't know if the question still holds.
But
Mr. Dung, I can't.
Mr. Masaba, the question is not on.
Sorry?
The question is not on.
Okay, so that was our first presenter. I don't know, when given chance, we'll always come back, Mr. Dung.
Okay, Mr. Masaba, thank you. Thank you. The next group, whoever is ready, can you put up your hand? Kibingo girls, did you come back? Kibingo girls, can you go on? My moderator, are you still there? Can you go on?
And when it's connected.
Kibingo girls, you have some.
My name is Chiringo Girls Secondary School, Shema Municipality, Western Uganda. I'm here to ask to go through number 50 from Curriculus 1. The question is, y is equal to e to the power time inverse of x. And we are expected to show that.
Kibingo girls, you have microphones open in your room. Kibingo girls, you have some microphones open in your room. Kibingo girls, you have many microphones open in your room. Kibingo girls, can you unmute? Can you unmute?
So we are expected.
Kibingo girls, listen to me. Kibingo girls, listen to me. You have so many microphones open in your room. You have microphones open in your room, Kibingo girls. Can you unmute now? Unmute Kibingo girls and speak. I think we need another school for now. Kibingo girls, you cannot afford to have 2 microphones open in your room. Chivingo girls, we cannot afford to have 2 microphones open in your room. Chivingo girls.
So now we are expected to show that 1 plus x squared, the 2y, the x2 plus 2x minus 1, the y dx, the y dx is equal to 0. So now given y is equal to e to the power tan inverse of x, we shall introduce natural log both sides. So we shall have ln y, which is equal to ln e to the power tan inverse of x. And from the laws of logarithms, we shall have ln y, which is equal to tan inverse of x ln e. But ln e is equal to 1. So now from this, we shall remain with ln y, which is equal to tan inverse of x. And from what we are expected to show, we are expected to look for the second derivative and the first derivative. In this case, therefore, we shall look for the first derivative of this. So we shall get dx of ln y, which is equal to dx of tan inverse of x. So now, let us first look for the derivative of this. So let's let tan inverse of x to be equal to a now unknown, say u being equal to x. In this case, therefore, now we differentiate with respect to x. So we shall have dx of tan u and dx of x. And when we differentiate tan, we get a sec square. So we shall have sec square u du dx, which will be equal to, when we differentiate x, it is to the power 1. So we drop the power and then reduce the power by 1. When we reduce the power, we shall remain with power 0. So it means that is a 1, because any number to the power 0, we get a 1. So it is a 1. So now making du dx the subject, we shall have du dx as 1 out of sec square u. Tan squared u equal to sec squared u. This is for the first identities of Pythagoras. So now, it means we shall have du out of dx as, we shall have du dx as 1 out of from here, we have that tan inverse of x is equal to u, so meaning b tan tan inverse of x is equal to u, if tan u is equal to this, so it means tan squared u is equal to x squared. So now this is the first derivative of tan inverse of x. So it means now differentiating what we have, it means if we have d dx of ln y and d dx of tan inverse of x. Now differentiating this, we shall have 1 out of u dy dx, which is equal to, now we bring in the derivative of tan inverse of x as 1 out of 1 plus x squared. So now, from what we are expected to show, we have the first and second derivative. And so, let us make the first derivative the subject of the formula, I mean dy dx. So now I cross multiply, and then I get the value of dy dx. So now I get dy So now I get the value of dy dx by making it the subject. I get y which is equal to 1 plus x squared. So now I get 1 plus x squared here. And from what we are expected to show, we have the second derivative. So now, to get the second derivative, it means we are differentiating this for the second time. Now we shall get d dx of dy dx, which is equal to d dx of y out of 1 plus x squared. So now, from this, we realize y dx is a quotient. So in this case, we are going to use quotient rule. And quotient rule, so it means for the second derivative, the 2y out of the x2 is equal to v. I am setting quotient rule because we have a quotient here. So I will have v du dx minus u is v dx out of v squared. And now from what I have this quotient, I can let u to be equal to y, and then also let v be equal to 1 plus x squared. Meaning I will differentiate u with respect to x, and I will also differentiate v with respect to x. Meaning from here, differentiating u with respect to x, du dx is equal to dy dx. And then for this case, v with respect to x, I will get dv dx. Differentiating when I drop the power here, it is x, but silent because it is a 1. It is
Hello? Pangole, we have lost your audio. We can't hear you speak. Kindly unmute, then put back the camera such
Kibingo,
and hear.
unmute.
Hey, it is keeping.
Kibingo,
And-
unmute. He's not hearing us either. Kibingo, Kibingo, we are asking you to unmute. Kibingo, unmute. Now, when we ask them to close out the other microphone, they cannot hear us anymore.
We
Kibingo,
realize we don't have y in the expression. So it means we shall look for a way of eliminating y by expressing it in what we already have. And from the first derivative, from dy dx, which is equal to y out of 1 plus x squared. So now from this we can make y the subject, and we remain with y being equal to 1 plus x squared dy dx. So here I have expressed y in other terms that we have related to what we have to show. So now I substitute the value of y into this, which means I would have the 2y, the x2 into 1 plus x squared, which is equal to 1 plus x squared dy dx minus 2x into the value of y. I have the value of y as this. So now it is my role to bring it and substitute it in here. So I have 1 into 1 plus x squared dy dx. So now from this, expression, I can see we are getting closer to what we are expected to show. So now having my the 2y, the x2 is equal to, it is into 1 plus x squared is equal to, now you realize we have a common factor here. It is 1 plus x squared y dx, which is common here and also here. So now we shall pull out the common factor in such a way that even when we expand again, we shall go back to the original function. So now I pull out 1 plus x squared dy dx. So I will have 1 plus x squared dy dx as a common factor. Then inside I remain with 1 minus 2x. You realize that when you again open brackets and multiply, you go back to what we had originally. Meaning now this is what is common. So now we divide by 1 plus x squared both sides. So now for this denominator will cancel with the 1 plus x here, and then this one will cancel because this is squared, meaning it will cancel with 1 of the 1 plus x squared here, and then we remain with 1. So we get the 2y, the x2 into 1 plus x squared. The square has disappeared because of the cancelling after division. So now this will be equal to 1 minus 2x dy dx. Now from what we expected to show, you realize the expression is equated to 0. So now we shall bring this one to this side and make it cross equal signs so as to create a 0 on the right hand side. So we shall have the 2y, the x2 into 1 plus x squared minus 1 minus 2x, the y, the x, and this is equal to 0. And from what we expected to show, we do not have subtraction sign here. How can we eliminate it now? When this subtraction sign enters the bracket, it will affect the 1, making it negative, and then it will affect the 2, making it positive. So we shall have 1 plus x squared, the 2y, the x2 plus, now the 2 is becoming a positive. So I have 2x minus 1. The negative is affecting the 1. Then the y, the x, is equal to 0. We are now successful. We have come up with what we expected to show from the question. Now let us tackle part B of the question. So now we are successful with part A. We are done with showing what we expected to show. Now let us handle part B of the question. And we have that differentiate cos of x squared e to the power x with respect to x. So it means they're expected to get d dx we are expected to have d df of cos x squared e to the power x. This is what we are expected to show. So now in this case, we are free to let y to be the unknown, which is equal to cos x squared e to the power x. And from this, we realize this is a product. So we shall look for a way of bringing in product rule in our solution. So now we shall let, I can let u to be equal to x squared e to the power x. So in this case, it means I would have my y being equal to cos u. Since I have let the whole of this angle to be equal to u, so I'm free to say y is equal to cos u. Now we shall differentiate. We shall differentiate u here with respect to x. So now, we shall have du dx as we first keep this and differentiate this, so we say it is x squared. When we differentiate e to any power, we first multiply by we first differentiate the power, multiply by the derivative, and then write the original function. So in this case, when we differentiate x, it gives us a 1. So 1 times e to the power x, meaning we remain with e to the power x, and then plus. Now we keep e to the power x constant and differentiate x squared. So I will have e to the power x as my constant. When I differentiate x squared, I drop the power, reduce it by 1, and then I remain with 2x. So it means I will have my du dx as x squared e to the power x plus 2x e to the power x. And from this, we realize that e to the power x is common here and here, and so is x. So we are free to pull out what is common, and we shall have e to the power x out, e to the power x. Then also x is common, so x is out. Then inside I remain with x plus 2. You realize when I open my bracket again, this one will take me back to this, and then this will take me back to this by opening the bracket. So we shall have e to the power x into x plus 2. And this is the value of du dx. So now I can proceed and get and differentiate y with respect to u. So I get when I have y equaling to cos u, I get dy du. When we differentiate cos, we get a negative sign. So this will be equal to negative sign u. This is negative sign u. So now, to get dy dx, because we are expected to differentiate what we have with respect to x, so I can get dy dx with this. I can get dy dx from chain rule, which says that when I have my dy du times du dx, now from this, when I count it enough, I already have dy du. So I get my value of dy du, which is negative sign u, and then multiply by du dx. I have the value of du dx as x e to the power x into x plus 2. This is what I have. So now I'm free now to bring in the value of u and substitute it here. So I will have negative x e to the power x into x plus 2, and then sine. Now I bring in my value of sine, which is x squared e to the power x. So I get x squared e to the power x. Remember, I had let y to be equal to, cos x squared e to the power x. So it means d dx of cos x squared e to the power x is equal to negative x e to the power x into x plus 2 sine x squared e to the power x. So now we have the solution with us, and this is what we are expected to get. This is the answer. The derivative of cos x squared e to the power x. I'm glad to have shared with you this afternoon. Thanks very much.
Thank you,
Any
Kibingo
questions from
SS.
anyone else there? You can pause it, and we shall have the response with you.
My moderator. I don't see any hands. Moyo SS. Thank you, Kibingo. Moyo SS. Moyo SS, are you going to present, or we bring Mbale SS again?
No, sir, we are ready to present.
Is is Moyo SS. Thank you, Kibingo SS. Let's go to Moyo SS. And my suggestion,
we are beginning by sharing our screen.
Bunyoro, what are you talking about? Bunyoro, do you want to present? Bunyoro, can you speak?
Moyo SS here, we are ready, sir.
Yes, Moyo, you are going to present, but I want to hear from Bunyoro. Bunyoro, what are
Fine.
you saying? Okay, Bunyoro is not speaking. Okay, Moyo SS. Moyo SS, can you start?
Good afternoon. I'm Alule Patrick from Moya SS. I am going to pick a question from analysis, question number 43, which says, find in that row x raised to power 3 p x raised to power 4 dx. In this expression, we are having both the function and the derivative. This implies that we shall use recognition, integration by recognition, whereby if we let our u equals to x raised to power 4, and we differentiate the u, if we differentiate u, we shall have du equals to 4 x raised to power 3 dx. Now, from here we make our dx the subject, we divide both sides by 4 x raised to power 3, and we shall substitute this expression from given expression, which says integral x raised to power 3 e raised to power, e x raised to power 4 dx. This will be equals to x raised to power 3 e u times our dx, which is equals to 1 over 4x raised to power 3 du. But our x raised to power 3, they cancel. And then we shall be left with 1 over 4 integral e u du. Now, when we integrate e du, we shall have e du plus a constant c. Now, since we know our u, which is equals to x raised to power 4, we substitute it. Then we shall be having 1 over 4 e x raised to power 4 plus c. I think that is a solution for part A. Without wasting time, we shift to part B, which says that use substitution t equals to tan x to find integral 1 over 1 plus sine squared x dx. Now, from this expression, we are to obtain tan x. So we divide the numerator and the denominator by cos x. Now, when we look at the numerator, when we divide 1 over cos x squared, we shall have sine squared x. And when we divide 1 by cos squared in the numerator, in the denominator, we shall have also sec squared x. Now let us also look at sine squared x. If we divide sine squared x by cos squared x, we shall have tan squared x. Now, from here, they have given for us this statement that says that our t is equals to tan x. Now, from here, we differentiate tan x. When we differentiate it with respect to x, we shall have sec squared x dx. And when we differentiate t, we shall have dt. Now we make the x the subject by dividing both sides by sec squared x, meaning we shall be left with dx, which is equals to dt over sec squared x. Now, from here, let us go, we substitute this value to expression which says that 1 plus tan squared x over 1 plus 2 tan squared x dx. That will give us that will give us 1 plus t squared over 1 plus 2t squared times dt over 1 plus t squared. 1 plus t squared divided by 1 plus t squared, they cancel, we shall be left with 1 over 1 plus 2t squared. Now we are going to use this expression. We are going to use t substitution, where we let our t, theta squared, equals to 2t squared. Now we get the square root. We shall have tan theta equals to, when we get the square root of 2, we shall have root 2, the square root of t squared is equals to t. Now from this expression, we can also make a theta the subject. We get the tan inverse. So we shall have our theta equals to the tan inverse root 2 times t. Now we differentiate tan theta equals to 2 equals to root 2t. When we differentiate tan theta, we shall have sec squared theta d theta equals to root 2 times dt. Now we make dt the subject by dividing both sides by root 2, such that we shall have dt equals to sec squared theta over root 2 times dt. Now this expression, since we know our sec squared theta is equals to 1 plus tan squared theta, we substitute it. Then we shall have dt equals to 1 plus tan squared theta over root 2 times dt. We go back to that expression, we substitute it back. We shall have 1 over 1 plus tan squared theta times 1 plus tan squared theta over root 2 times the theta. 1 plus tan squared theta, they cancel. We shall have integral. We shall push out the constant, which is equals to 1 over root 2. And then we shall be left with 1 over root 2 integral theta. Now, when we integrate that, we shall have 1 over root 2 theta plus constant c. But since we know our theta, which is equals to tan, arctan root 2 theta t, we substitute back, then we shall be left with 1 over root 2 arctan root 2 theta plus constant c. But again, we know our value t. Our t is equals to tan x. We substitute in that expression. Therefore, give us 1 over root 2. 1 over root 2 arctan root 2 tan x plus c. I think we are done with the part B, and I am done with my question. If there is a question, someone can ask, and then I will respond.
Can you take over?
Come again, sir.
Would you take over the moderation and see how we move from here? Who next? Or if there is a question?
Huh? Hello. Yes,
We
please.
want you to guide us. Who is coming next? Is there like suggested?
Applied?
Yes. Is there anyone with applied? Come next.
Not very ready. We are proposing that may you please organize it like maybe next time or another day.
Oh.
So that we exhaust paper 2.
Okay.
Okay.
But I also know, I see that we are getting late. Is there another school here that is ready to present?
Yes.
Which one? Yes, I wanted to suggest.
Yes.
That we take Mbale SS, although I wanted us to go back to the main room, but let us have Mbale SS here.
Yeah, are you able to get us?
Now it looks like
yes.
It looks like the others have. It looks like they've moved back to the main room. Can we go to the main room? And Mbale SS could present from. Okay. Okay, let's have Mbale SS before we go back. Let's have Mbale SS.
Okay, are you able to get us?
That should be the last one.
Are you able now to hear us?
We should be able to hear you.
Are you able to hear us?
Yes, we can hear you.
Okay.
My name is James, student of Biases. I'm going to present a question in the topic of geometry and on the subtopic conic section. And that is number 30. So it reads, a conic section is given by x equals to 4 cos theta, y equals to 3 sin theta. Show that the conic section is an ellipse and determine its eccentricity. So we know that ellipses are written in the form of x squared over a squared plus y squared over b squared equals 1. So how are we going to achieve this? We are going to, since they have given us the parametric equations as 4 cos theta, so we are going to square this. So we are going to square x and we are going to square y. So x squared will be equals to 4 cos theta squared. So x squared equals to 16 cos theta squared. So I'm also going to square y sine, the y equals to 3 sin theta. So y equals to 3 sin theta. So y squared equals to 3 sin theta squared. So y squared equals to 9 sin squared theta. So this is our second equation. So we are going to say equation 1 plus equation 2. So from here, it will be now x squared.
Mbale, we are not very clear. You are not very clear, Mbale.
We have to calculate. Okay. cos the subject from here.
You are not very clear. We don't see you well. The camera is far. Oh.
X squared over 16 equals to cos square theta. So that is how I put one.
We can hear him, but the camera is not clear.
Okay. Okay. Then we are also going to make one the subject from equation 2. So y squared over 9 give us sin. Is it clear? So now equation 1 divided by 2. So when we divide equation 1, 16 plus y squared over 9 will give us cos.
Can you zoom in a bit? Please zoom in.
But we know from Pythagoras that this is from cos squared theta plus sin squared theta equals to 1. So this is going to be 1. So therefore, x squared over 16 plus 1 over 9 plus and we are proof that and LX. So we are going to determine the eccentricity of this point. So the eccentricity is from b squared equals to a squared into 1 minus squared. So from here, our b is this one. See, our equation of 9 is written in the form x squared over a squared plus y squared over b squared equals to 1. So which means our b squared is 9. So we are going to put 9 in here equals to 9 squared equals to 16 into 1 minus e squared. So from here we shall have 9 over 16 minus e squared. So it comes, we bring b this side and then we take 9 this side. E squared equals to 1 minus 9 over 16. We get the LCM, which is 16. So this is 16 minus 9. So from here, we shall have, when we subtract this, we have 7. So E squared equals to 7 over 16. So we get the square root of this, root of 7 over 16. So this is root of 7 over 4. So this is our eccentricity.
Morgan, I don't type in what is name? Who's that?
Given that the line y equals to plus c is x squared over a squared plus y squared over b squared equals to 1. So that c squared equals to a squared m squared plus b squared. Then determine the equations of the tangent at the point -3 to the ellipse x squared over 16 plus y squared over 9. So we are going to have from the equation they have already given us over a squared plus y squared over b squared equals to 1. So we are going to get the LCM from here. So we shall have x squared b squared plus y squared a squared equals to a squared b squared. I hope we have all known our written here. I've just gotten the LCM and then multiplied it on all the sides. So from here, we know that our y was given as fx plus c. So x squared b squared plus, now we put this in place of f of 1 into a squared equals to a squared b squared. So from here we shall open this. It is squared here. X squared b squared plus when we expand this, the square of this shall get m squared x squared plus 2 cmx plus c squared a squared equals to a squared b squared. From here, we shall go to shall now expand here. X squared b squared plus a squared m squared x squared plus 2a squared cmx plus c squared a squared equals to a squared b squared. From here, we shall now collect the like terms and put out the x squared and then the x. So b squared equals plus a squared m squared into x squared. Then plus 2a squared cm x plus now c squared a squared minus a squared b squared equals to 0. We see that this is a perfect square. So the perfect square, when it is a perfect square, so b squared will be 4ac. So from here now, this is our a, this is our b, and this is our c. So from here we shall now put the all of this to a squared cm squared equals to 4 into b squared plus a squared m squared. Then c is this c squared a squared minus a squared b squared. So now when we expand this, it gives us 4 a power 4 c squared m squared equals to, this is now 4 b squared. So we are heading out with this. 4b squared times this gives us c squared a squared. This times this minus 4 squared b power 4. Then plus 4a squared m squared okay. This is 4 a power 4 c squared m squared. Then plus 4 a squared a power 4 m squared b squared. And these are the same. So if we bring out this to this, it will give us 0. So this and this they go. So 0 is 4 b squared c squared a squared minus 4 a squared b power 4 minus 4 a power 4 m squared b squared. From here, we shall bring this one to the negative this side. So 4 b squared c squared a squared equals to 4 a squared b power 4 plus 4 a power 4 m squared b squared. So from here, 4 b squared a squared c squared equals to 4 a squared b power 4 plus 4 a power 4 m squared and b squared. But we see that b squared and a squared are common and 4. So 4 b squared divide it on both sides.
Mbale,
So
we can no longer see anything. Mbale, You better erase and write big letters.
Try
I
to
no
write
longer
big
see
letter.
anything.
Write this. Come this way.
The camera is not appearing very well.
The camera, please use double columns. Use double columns. Don't use one column.
Okay, okay. Just use double column.
You'd rather erase many times, but we need to see what you are writing.
Pardon?
Camera is far from the.
We would rather erase many times than you writing small letters. So you use double columns. And let the camera focus on the board and not on the person. We don't want to see the person, we want to see the mathematics on the board.
Okay, sir. Let it be divided by board being divided by each.
Okay, sorry for that. So we are going to have 4b squared, a squared, c squared equals to 4 a squared b power 4 plus 4 a squared a power 4 m squared b squared. But we see that 4b squared a squared are very common in the two equations. So we are going to divide by 4 b squared a squared over 4 a squared b squared. So this and this. So we are left with c squared equals to, we are left with b squared plus a squared m squared. Therefore, our c squared equals to a squared m squared plus b squared as required. So now we are going to the next. Hence, determine the equations of the tangent at the point -3 and 3 of the ellipse x squared over 16 plus y squared over 9 equals to 1. From here, we shall get the LCM here. So our LCM is, okay, 9x squared plus 16 y squared equals to 16 times 9. So our 9x squared plus 16 squared y squared equals to 144. So we are going to differentiate this. We are going to differentiate this equation. So it will be 18x plus 32 y in dy dx equals to 0. So 32 y dy over dx will give us 18 negative 18x. So dy over dx is negative 18x over 32y. From here, they have given us the point, which is -3 and 3. So we shall have at -3, 3. Our dy over the x gives us -18 times the value of y of x, which is -3, over 32 and the value of y, which is 3. So dy over dx equals to 54 over 96. So this is so as we reduce this gives us 9 and this 16. So dy over dx gives us 9 over 16. So this is our gradient. From here, since we know that the tangent is a straight line, so which means this is our point, which is -3, 3, and this is any point, which is we now call it xy. So from here, shall have change in y divided by change in x. So it will be now y minus 3 over x minus -3 equals to y x. From here, our y -3 over y over x plus 3 equals to 9 over 16. So we cross multiply. So y minus 3, 16 equals to 9 into x plus 3. So now this is 16y minus 48 equals to 9x plus 27. 16y equals to 9x plus 27 plus 48. Plus 48. So from here, it means our 16y equals to 9x plus 75. And this is our equation of the tangent. You can either further simplify by dividing by 16, or you leave as this. Thank you. Any question?
Mr. Masaba,
Yes, sir.
is that complete?
Yeah, it is complete, and the
I think
presenter is asking a question if it is there at all.
My suggestion is that we go back to the main room.
Okay.
And let's find out if there is anyone here who is still willing to present, because group 1 is still there in their room, but I wanted us to go back to the main room and we do a presentation so that group 1 finds us there. Anyone here willing to present? Mbale, do you still have another presentation?
Yeah, we still have.
Okay, members, please click on leave room and go back to the main room so that Mbale SS can now present from the main room. Mbale SS, please go to the main room and start the presentation. Mbale SS,
Okay, sir.
the main room and start the presentation. Everyone here, click on leave room, leave breakout room. When you click on leave room, you click on breakout room. Don't leave meeting. Leave breakout room and go to the main room. Mbale, go and start the presentation.
Okay.
Getting late, we need to get group 1 out of their room also. Each one of us here should go back to the main room. So when you click on leave room, you go to leave breakout room. Mbale SS, you are still here. Mbale room 1, you are still here. Please click on leave breakout room. Whoever is still here, click on leave room. And when you click on leave room, it says leave breakout room. Yes, we are learning quite a number of things here.